So started a questionnaire. What's the shape of the Earth? Is it flat or is it a ball? I'd be interested what people vote for that come by here. So I want to talk about Zoom. Important to understand as well when you want to understand more about the shape of the Earth, about astronomy or something like that. What's Zoom? Zoom or Zoom experiments. When people talk about Zoom experiments, or what do I mean by that? Some people go to lakes or to still water, to any kind of still water. They must be large. Lakes like you'll find in America somewhere, um, not so much in Europe. There are large bodies of water that are still, and some people make zooming experiments. For example, they say, okay, a ship is not actually going beyond the horizon, it's just getting smaller. And then you can bring it back with a high zoom camera. But is that really true? High zoom camera. What is zoom? Let's first talk about what is zoom. What do we do when we're zooming? We're not actually decreasing the distance. So an object from our eyes or our position on Earth has a distance to us. It's very far away and we're looking at it through a telescope or through a camera that can zoom. What are we actually doing? We're not decreasing. We're not decreasing the actual distance, the physical distance. We're basically deceiving our own eyes with a trick. And these are, for example, lenses that are built into telescopes. And what it does is use the light that is reflected off of objects that are far away from us and then magnifying these objects. That's what lenses do. So it's not in truth an increase or a decrease of distance when you're using zoom, when you're using a telescope, or when you're using a digital zoom, because there is also a digital zoom which is even worse, because all you're doing is just cropping an image, right? You have a digital camera, for example your phone camera, that has a zoom function. What you're doing is basically just photographing something or holding the camera at an object, and when you're zooming in, it's just cropping the digital image. It's not zooming in any kind of way. In truth, it's not decreasing the distance. In truth, it's just cropping an image. That's the digital zoom. Then you have a more mechanical zoom, which is, of course, using lenses, for example, in cameras or in telescopes. And what they are doing is also not decreasing the actual distance to an object. All they do is fool our eyes by magnifying objects using lenses that use the reflecting light of objects that you're looking at. For example, you're looking at a ship at the horizon. That ship is being highlighted by sunlight. Sunlight is reflecting off of that ship. Then you stand at the beach, you're looking at it with a high zoom camera, with a lens, okay? And then you're not actually decreasing the distance to the boat, to the ship. What you're doing is just using the light plus a lens that then can magnify objects in distance. But the magnifying effect is just a visual deception again. It's not in truth decreasing any distances. And that's why you cannot actually see Even with a telescope at the bottom of a beach, you're standing there with a telescope, you cannot see beyond a certain point because there is a horizon line at a certain distance, and since you're not actually decreasing any distance when you're looking through a telescope, but you're simply using a lens, it's a trick, you're using a lens that uses light to magnify objects in distance. But once there is the horizon line, you cannot go beyond that. Even with a high zooming camera, even with a high quality telescope. Okay, because the horizon line is the ground, the surface underneath your feet that is moving upwards to your visual perception, okay, and then creating this barrier, visual barrier, okay, at a very far distance. That could be 5 kilometers, okay. When you're at close to sea level, standing at the beach, then your horizon line is around 5 kilometers ahead of you, or 3 miles if you're in another measurement. And all you're doing when you're zooming, whether that's through a digital zoom or a mechanical zoom, not a physical zoom, but more of an analog zoom, if you want to call lenses analog. All you're doing is again fooling with your perception, using light in the case of an analog lens, camera or telescope that magnifies objects using the light, okay? And a lens has a certain, it's either concave or convex, and that can either magnify objects or micrify objects. It goes both ways depending on how the lens is shaped, and then also depending on the incoming light, of course. If you have an object that doesn't give off much light, it doesn't work. Okay, and the digital zoom is simply just cropping a digital image. That's what you're doing on a phone, for example. If you have an image, you've taken a photo, and you can just zoom into it by swiping or using 2 fingers. Then all you're doing is just cropping the image. You're not actually decreasing any distances in reality. The same with a digital zoom in a more live stream way. If you want, you're holding the camera somewhere, for example at a ship that is at the horizon. All that's happening with a digital zoom is that you're cropping an image that the phone camera is taking. It always takes the same image, but all you're doing is cropping the image so it seems to you that it's closer. But of course, in truth, you're not actually decreasing any distances. And that's very important to understand, that people ask, right, if the Earth was flat, why can't we take a high power telescope and just look from Europe to America, or from America to Europe, anywhere, right, on Earth? Because they assume, okay, it's flat, so we could just look as far as we want. But that's a fallacy in thinking, because there is a horizon to every body. Everybody has a horizon. Every viewpoint has a circumference with a certain radius and a horizon. The circumference is the horizon. The ground underneath the viewer, the observer, is actually bending upwards or moving upwards towards that horizon. When you're looking, for example, at the horizon at the beach, then the ocean seems like it's moving upwards towards the horizon line. But of course, in truth, it doesn't do that. But still, you get a visual barrier, which is the ocean. It is all visual in the end. Okay, the further things move away, it becomes more elusive. The more visual it becomes, the less actual physically it becomes. Okay, because you're using your eyes to see something in distance. So when a ship reaches the point of your horizon, it just goes beyond that point because it can move. Of course, it's an ocean. It can go further than that, but to your perspective, to your position in relation to that ship, the ship is increasing the distance, but between you and the ship is the horizon. Okay, and it's blocking your view. That's all it does because of perspective. So even with a high power telescope or a P900 or whatever these are called, these cameras, they can really zoom very, very high, very, very far. Well, you would have to say actually they can magnify objects very big because they don't actually go into distance, or they don't change the distances. And that's the whole point. If you have a horizon line, all you're doing is just zooming into that horizon line. And that horizon line has a certain limit. It's, for example, 5 kilometers ahead of you when you're standing at the beach. So there is a certain limit. All you're doing is just, with any telescope or high power camera, high zoom power camera, all you're doing is just magnifying that visual limit, okay, which is the horizon. So anything that goes beyond that, you can't see anymore, okay? It will disappear bottom up, as ships do at the horizon. Once they move beyond that line, they just disappear bottom up. They get smaller, okay? But they might still be big enough when they have reached the horizon for you to see them. Okay, so what happens is that the horizon line uh, pushes itself between your eyes and the ship. And that's why the ship is disappearing bottom up until you cannot see it anymore. Okay, going beyond that horizon. Earth does not have to be a ball for this to happen. And again, if you're standing at the beach and you're using a telescope, all you will do is just magnify that horizon line. There is no telescope that can see beyond the horizon, because all of this depends on perspective. Again, you have a viewpoint and you have a horizon line that is basically a circle around you with a certain radius, and then you have this huge circumference around you, which is the surface of Earth. It could be ocean, it could be a field, it could be, I don't know, any flat surface. But the main point is that that surface that is under your feet into distance, when it goes into distance, it will move upwards to your vision and creating a barrier, a visual barrier between you and any object that goes beyond that horizon. Okay? Also on a flat Earth. Earth does not have to be a ball in order for you, for us all, to see ships disappear at the horizon, or a sun going beyond the horizon, or moon and stars and all of these kind of things. It's again about perspective. And zoom does not decrease distances in reality. All that zooming does is either digital zoom cropping a digital image, okay, or more analog zooms are using lenses that then are using light to magnify objects that are in distance, in high distance, but in truth, you're not actually getting any closer. It's a deception. Zoom is a deception. Okay, there is no such thing as a optical zoom in the sense of that it decreases distances. All it does is fooling your eyes with tricks. That's what zoom is. Either digital zoom, cropping an image. You have, for example, certain pixel. You have a pixeled frame. You have millions of pixels. Okay, when you're not zooming, it all looks nice. You don't see any pixels. But the further you zoom in, because the image is just cropping, the more pixels you will see, and the less clear the image gets. Simply because it's a digital zoom. It's not actually decreasing any distances in reality. And with a telescope, the same thing. Okay, but a little bit different, of course, because it's not digital. It's not cropping an image. What a telescope does is use light and a lens that magnifies objects. The light goes through the lens and it magnifies the object, and when you're looking through the lens, then you see the object bigger, but it does not decrease any distances in reality. And that's very important to understand why you cannot use telescopes to look from Europe to America, even on a flat Earth. It's not possible because at some point you will have a horizon line and that is blocking your view. Also for telescopes. It's just like your eye, but now you're using a lens which is bundling light or dispersing, let's call it dispersing light in a certain way so that the object that you're looking at through a telescope seems to be bigger, but it's not really decreasing any distances in reality. So all you do is just look at the horizon line, where the horizon line is from your perspective, from your viewpoint. For example, you have a viewpoint at the beach, then you have a radius which is 5 kilometers, around 5 kilometers, okay, or 3 miles. Then you get a circle around you, and that's your horizon line. It's a visual limit. And you're looking at physical matter. That's why it's blocking your view. You're looking at an ocean, for example. It's physical matter. It's water. You cannot look through that. And because the further things move away from you and the ocean is underneath your feet, it moves upwards towards the horizon line and creating this visual barrier. So even if now you take a telescope and you're zooming into that horizon line, you cannot see any further than that, because the horizon line again is linked to your position. There is a real distance, but with the telescope you don't decrease the distance in reality. All you do is just use a lens and use light together to magnify an object. That's also what refraction does. Refraction does this naturally. You have, for example, humidity in the air, then far objects like the sun will be magnified because of light dispersion, not because the sun is actually decreasing in any distance, no, just because the light passes through the humid air and it creates an illusion for your eyes that the sun appears to be bigger. Sometimes, you know, when you watch a sunset, sun comes down and the sun appears to be so big all of a sudden, much bigger than it was before. And that is because of refraction, because of the layer of air that you're looking through, or the light has to pass from the sun to your eyes through this layer, and there is humidity, there is water in the air, there are particles in the air, whatever. It magnifies, it disperses the light and magnifies the object from where the light is coming from. Okay? That's also a reason why the sun doesn't get any smaller, visually smaller, when it sets. Because people think that, oh, um, they just take that image, for example, of lampposts, and they know, okay, they understand, okay, because of perspective, lampposts go down towards the horizon. All the lamps are moving down towards the horizon, like they're setting. If you can follow, you have like a row of lampposts along a road that is straight, and the lamp is above your head, and each lamppost has a lamp, and each lamp is towards the horizon, decreasing in altitude. So you get this nice falling shape towards the horizon, and you would say, okay, the lamppost that is close to me, the light is very visible, very big, but the further it goes away, the smaller it becomes. Simply because the ratio is a totally different one. You're looking at a lamppost that is just a few meters away from you, and then you're looking at a lamppost that could be 2, 3, or 4 kilometers away. Okay? So that's why it visually also becomes smaller, but with the sun, it's already far away in the sky. It's already so high up in the sky, away from your position, in high altitude, that when it does its movement from east to west, rising in the east, setting in the west, it almost keeps its size, but also it's deceivingly keeping its size, because at the sunrise and at the sunset, you're looking through this layer of air that disperses light and magnifies the sun, the object, right? It does not truly magnify the sun, but visually magnify it, okay? Because your vision depends on light, and light is then being dispersed through this layer of air, which magnifies objects. So they don't, or this layer of air does not decrease the distance. In reality, it's just a visual illusion again. Okay? So that's how you can have a sunset, sunrise, or the sun in midday, and the sun keeping its size, seemingly keeping its size throughout the whole day. Okay? So if you want to know about zoom and how digital zoom works, or the analog zoom, I've explained it now in this live. This live will be up in a few minutes. You can rewatch it if you want. I will close it here. Just see what the comments were. What's the shape of the Earth? Flat. 56% flat. I'm surprised. People vote for that. Ball 44%. Okay, so yeah, there is a lot of evidence out there to determine that the Earth is not a ball. You just gotta bring it together. People should be allowed to talk about it. It's the physical truth, right? The physical shape of the Earth. And that's about it.